your mic, Nate. Dave Moore here with the Idaho Technology Council. Thanks for being here for the virtual event. We got Nate Monnig. This is the first time we're trying to do a more involved kind of presentation on the Hopin platform. Really hoping it works out so that we can use this type of a setup and develop Idaho in the future as well. Please feel free to put your questions right in the chat and we'll get them asked to Nate as the presentation's going, and hopefully the audio was the only issue we had. And hopefully it's working. All right, here we go, Nate, go ahead.
All right, try to get this back in place. It's an awkward little microphone, but. All right, thank you so much. It's an honor to be here. Excited to be sharing some thoughts about how to help researchers, data scientists be more effective in their position and be more valuable to their businesses. So I'll jump right into it. I'm going to start with an introduction to a little bit about who I am, a little bit about Count and what Count does. And I'm going to talk about what, in my opinion, is a relatively typical data science workflow, and then go into some new thoughts about how we might be more effective, tweaks to this workflow to improve our ability to deliver. But before getting into the material, I wanted to thank some people, make some acknowledgements. So first acknowledgement is the entire software development community. I know this sounds kind of ridiculous, but I just wanted to highlight that these ideas are not really new. What I'm trying to do here is harvest some useful concepts from software development and bring them into broader use in the data science community. Software development has been around a lot longer than data science. Data science is really a pretty new field. And I think there's a lot we can learn from some more established patterns from software development. I also wanted to acknowledge there's been numerous individuals at Count and Equifax who have provided great assistance and feedback. But I particularly wanted to thank Chris Galley, our Director of R&D, for not only collaborating on a lot of the work that grew these ideas, but also really just like informing a lot of this thinking. A lot of the origins of this thinking, at least at Count, came out of an initial collaboration between Arthur Putnam, a former data scientist at Count, and Chris. I got involved with Chris more recently and got really excited about some of this stuff. Yeah, just excited to be here. Finally, I want to thank Andrew Rothla. He's one of our machine learning engineers, and he put in a lot of work helping develop the platform that really enabled me to explore these ideas more fully. All right, so a little bit about who I am. I've had kind of a long and sordid, messy history through the sciences and mathematics, getting to where I am. So I started by earning my bachelor's in physics and went on to a master's program in hydrology. After that, I spent several years working as a hydrogeologist at Golder Associates. So I was doing a lot of contaminant transport modeling, numerical models for groundwater flow, trying to understand how chemicals dissipate in the subsurface, how we can contain them or limit the spread. And over those years, I came to really realize that what I loved about what I was doing was the math, and I wanted to understand that better. So went back for round 2 through graduate school and earned my PhD in applied math. It was during that time I got really more interested in data and algorithms to analyze data. I did a lot of research work in how to leverage graph algorithms to analyze high-dimensional and large data sets. It was sort of the early days of, I think, what became machine learning and data science. And we were doing modern signal processing, a lot of those sorts of things, using ideas from the signal processing community pretty extensively. After earning my PhD, I worked at Numerica Associates in Fort Collins, Colorado. It's a relatively small R&D oriented technology development and research company. We worked on a lot of interesting government-funded research projects in like cybersecurity and air and missile defense applications. Finally, 3 years ago, I moved to Boise to take a job as a data scientist at Count, where I've really had a great time exploring strategies to leverage pretty vast data assets that we've collected over the past many years to improve our fraud detection capabilities. All right, so I'm sure there's certainly people who know Count very well, and maybe some folks who have never heard of Count. So Count is a software as a service company in downtown Boise. It was actually founded 13 or 14 years ago in Boise, and has been here ever since. We have about 200 employees now, and we're a leading provider of third-party digital fraud protection services. So our core business over the years has been digital payment fraud detection, particularly card-not-present transactions, though we process all kinds of digital payments and financial interactions. And as the company has grown in the recent years, we're expanding into a lot of other related fields, like account takeover protection. Our company was acquired, you may have heard, by Equifax in February 2021. All right, so here's my real overly simplified view of where Count sits in a typical payment interaction in the digital world. So if you are looking to purchase something online, and you happen to be trying to do so from one of Count's merchants' websites, you're going to be on the merchant's on the merchant's checkout page, and you're going to put things in your cart, and then you'll start filling out all your information, right? Your payment information, your name, your address, your phone number, all this. And when you hit submit, that's going to get shipped off to the merchant, obviously. Well, they're going to turn around, and if you're purchasing, for example, with a credit card, they will need to authorize that card with the bank, and that's the bank authorization step here. And if they're a Count merchant, they're also going to do a fraud analysis with Count. So they're going to send that information to us, and in our very low response time, 250 milliseconds, we're going to turn around that response. We're going to take all that input data, device information, and do all kinds of analysis on that in real time. So we'll do data augmentation, feature engineering, and then process all the features through a large machine learning model, which we've trained on historical data. We'll execute a rules engine custom for that merchant, and then produce a response, either approve, review, or decline the order, along with a bunch of other data. All right, so marketing slides, I've got a few. We work with lots of brands you'd recognize, so we process lots of interesting data, and have a whole variety of use cases. So here is a broader view, a more marketing type depiction of what it is that Count does, of our whole suite of products, because we go well beyond just card-not-present transactions. I'm not going to go into the details of all these different products and services, but my reason for bringing up this slide is to sort of note that Count has a pretty complex business, and as data scientists at Count, embedded in this large organization, we need to be thinking about a lot of different things and contributing, and we're getting pulled in different directions. And there's a lot of competing priorities for development resources. Okay, so what does data science look like at Count? We currently have a team of 4 full-time data scientists, and it's a highly cross-functional role. We collaborate with teams all across the organization. We're working very closely with our product team to look to the next horizons of the development of the business and our products. We work with sales and marketing for an understanding of what the market needs. And obviously, we're data scientists. We need access to data. We work a lot with our data warehouse team. We also want to know how things are working now for our customers how our solutions are working. So we collaborate a lot with our business intelligence team. And finally, if we develop an idea that is going to move into production, we collaborate with various cross-functional development teams to actually productionize the concept. And what are our tasks? Broadly speaking, there's at least these three things that we are responsible as a data scientist. So first and foremost, it's monitoring and maintaining what we've already built. We need to know how well it's working. We may need to retrain a model, other things like that. And we're also always looking for like incremental improvements to those models, those AI services. And then the third bit, which is where I'm going to focus my discussion today, is we're tasked with a lot of research into the potential new technologies, the new directions we can go by leveraging Count's data assets. All right, so here's my depiction of a typical data science workflow for this product development, this technology development thing. Just as a reminder, I meant to mention on the last slide, those other roles, those other hats we wear, the sort of maintenance and incremental improvement things, again, are really important parts of what we do, but I'm going to focus on this R&D type role and this R&D task. So we're a business, we want to get paid. Where do our ideas come from? Like everything we build should be solving a problem and therefore something that we can get paid for. So we tend to harvest our ideas from our customers, from the market. Is there a customer complaint that keeps coming up? And we need to build something to help this pain point for our customer. Or is it some sort of market research? Is it a competitor has this and now we're losing bids? Is there some reason, some checkbox our sales team can't check in the sales pipeline and they can't close a deal because we're lacking something? So once we have that idea, data scientist goes off and starts digging around in the data. We use Snowflake for our database of record, our data lake, and we spend a lot of time writing SQL queries, just exploring the data, see what's possible. If it looks like this idea might have legs, if there's potential, then we're going to go into sort of a model or algorithm development phase. This might be training machine learning models. This might be writing our own algorithms to solve the problem or complete the task we're after. We happen to use Spark or PySpark running on Amazon Elastic MapReduce clusters. We interface to these clusters through a Python Jupyter notebook. And it provides just a really nice interactive interface to do some powerful parallel computing, but still in a really interactive way, so we can still explore, but also go all the way to training a production model, all in this environment. And finally, once you sort of completed the research task, if you will, you have your results, whatever they are, you should document them. So write down your methods, your experimental results, your conclusions, your recommendations, whatever that is. We use Confluence extensively for our documentation. We also use MLflow for experiment logging. We'll log artifacts, plots, metrics. We'll also log the code itself from the Jupyter notebook in particular that was used to generate that experiment. We really believe that science is part of data science, and a key part of science is that it's reproducible. And if you have the code and access to the same data, you can reproduce an experiment. Finally, you got to spread the word, right? There's all kinds of competing objectives in a large organization. And if you think you've invented the next coolest thing, you have to go out and convince somebody that you have, in fact. So you got to spread the word, share your results. So in my experience, I have done it myself. I've seen many people do it, go through this pipeline, get to the end, and that's just sort of the end of it. You get a couple meetings, people maybe read your Confluence page, maybe nobody does, maybe you get a thumbs up on your Confluence page, and that might be the end of it. So My question, and the question I've been exploring, is like, is there improvements or modifications to this pipeline that can help us be more effective, help us learn more? So I'm going to throw away the documentation and spreading the word bit, sort of. All right, so here's a slight change to a similar pattern. So the goal here is still thinking in the research domain to actually go build an API is the end goal. So again, we're going to start with the same, source of ideas. Again, we want to build things that are useful, that somebody wants. But we're going to immediately start talking very clearly about the interface. We're going to define the API, if you will. And I think this is something that's often overlooked in the data science realm and other research domains. It's easy to just think, oh, I'm just sort of doing research. I don't know where this is going. I don't know what the ins and outputs of this algorithm are. And you don't really have to know all of that, but you should have an idea, and you should start somewhere, and you may iterate on that. And as I get through more of this presentation, I hopefully demonstrate why that's so valuable. Again, the sort of research phase itself is not going to change much. We're going to, after determining an interface, really establishing some parameters for this potential technology, we'll do data exploration, we'll do model and algorithm development, and then rather than just going and writing a big messy Confluence page detailing all the details of the work, we're actually going to go build a functioning prototype or a demo. And again, do what a developer would do. These are the ideas that we're just sort of taking from somewhere else. I'm not actually suggesting you should throw away your documentation. I think that's a really important part of research. Again, the reproducibility. I just don't think it's a great way to like convince anybody you've built anything valuable and communicate to others. Like nobody else. Don't expect other people to read your Confluence pages, at least not in the detail you'd like them to. But you're really going to want to potentially go back to that documentation in the future. If somebody 2 years from you asks, like, why did you make this decision and train the model this way? Or why did you use this algorithm over that? Or why did you not push this idea forward? You want to be able to go back to your notes and figure out why and explain very clearly. And in that vein, I would also just as a side note sort of encourage, like, we have to document both successes and failures. I've been in so many meetings where somebody brought up like an idea for something that we could do, and somebody else said, oh, we tried that 4 years ago. It didn't work. It's like, well, let's go to the documentation and figure out exactly what was tried 4 years ago and figure out, are we really contemplating doing the same thing, or is it something different? Do we have new data available? It might be possible to do the same thing now just because we have new data and a whole host of other reasons. Maybe we're not even talking about the same thing. All right, so as we get into these ideas, I really want storytelling to be something that we're all thinking about. So why storytelling, and why do I think we need to be better at it? I was really on the fence about this quote because I know Steve Jobs and Apple is like amazingly divisive. Like people love Apple or they hate Apple, and probably same with Steve Jobs. But whether you like him, I'm personally kind of agnostic. I don't care. But whether you like him or not, I think you would most likely recognize him as a successful and innovative person. And he is at least quoted online as saying this: the most powerful person in the world is the storyteller. The storyteller gets to set the vision, values, and agenda of an entire generation that is to come. Maybe a bit lofty goals for your average data science project, but still something to think about. Like, how do we make an impact on other people? Why do we need to make an impact on other people? So this quote I really like. In my many discussions with Chris Galley, our director of R&D at Count, he shared these observations about the world. And I think it's a really interesting and powerful sort of view and observation about the world that he made, that it's our ability to create shared narratives that underpins much of human progress. We need to be on the same page when we're trying to build something. And as he shared with me, when he starts working on a net new idea, he's constantly trying to get a shared narrative established between product and technology about what they're trying to create. And this shared vision and story about the world helps work together, helps them make informed decisions and trade-offs, and helps the team change course when they encounter new learnings and obstacles. So how do we as data scientists help develop a good shared narrative? Well, one thing we often produce from our experiments is metrics, right? We train a model, we train 2 models, we get metrics, right? So the question is like area under precision recall or the curve itself, like is that a useful tool for developing a shared narrative? It may be within the data science team and among some of the other technical people at your company, but I would argue that this is not a great way to establish like a shared narrative with the product team, with the sales team, with other people at your organization who do not spend all day thinking about precision and recall and the trade-off between false positives and false negatives, things like this. So once again, I'm not advocating that you throw away your metrics. Ask any of my coworkers, I'm like a staunch advocate for having metrics for success and using them to guide your algorithm development, your training, anything, right? Like if you don't have a good metric for success that is operationally relevant, then you're not gonna be able to tell whether algorithm A is better than algorithm B. But this should not be what you point to help develop that shared narrative. But what you should point to, I think, is a demo. So we've talked a lot as we've sort of noodled on these ideas recently about the just show me, don't tell me. And for this, I'd like everybody just like have a little thought experiment in your mind and just think about like how much time you personally want to go spend reading a Confluence page about somebody else's project. It's some research project a coworker has been doing. It's interesting and important, but it's not really what your focus is. And they ask for some feedback. They say, hey, I think I got this cool idea. Like, can you read it? Can you give me some feedback? You're probably not going to give it the level of attention and detail in that read that they would really like. And that's going to go for you being on the other end of that. But if they just sent you a link to something they could go, like a toy they could go play with, a data-driven demo, like I think you're going to get way more engaged. And you're going to look like this. You're going to be so excited. All right, so I think there's a whole host of benefits to this concept of API-driven data science. So early in the process, I think it's really valuable, again, this first step of establishing the interface, like before we really even dive into the research. Because it's going to help you help data science and product or other research teams align with product and other stakeholders on exactly what the objectives are of this work and set some expectations about what we're trying to produce together. Obviously, the product team should be thinking about exactly what the envisioned product should do, but as a data scientist, you should be engaged in those conversations as well. And then, obviously, knowing what exactly the envisioned product will do, you need to ask the questions like, is it going to meet the needs of current and future customers? Again, product questions, but a data scientist should not hesitate to be at least involved in those conversations. Because this last one is key. Is the envisioned technology that the data scientist or the researcher is going and trying to develop a prototype for, is that can actually meet the requirements of the product? And that's where it's really important. Like, talk very clearly about the interface. Like, I've been a part of it myself. I've seen it happen elsewhere where we had some vague discussions, some really like lofty but sort of vague discussions about a concept for a technology and a product that we could build around it. And then we went off and a data scientist, me or someone else, spent potentially several months working on some research, we got back together, and after like a half an hour, sort of eventually came to the realization that like we were not aligned in that initial conversation, and like we need to pivot the research because what we've prototyped here, this idea we've tried to bear out, is not going to fit in the envisioned product. I think there's a host of benefits to the researcher themselves. I've experienced this myself. Like, first and foremost, like, should we be even be doing this research at all? Again, back to the previous point, like, is the right data going to be available at the right time? Where is this going to fit in your like potentially very large and very messy architecture of your whole system or suite of products and technologies? Are downstream consumers going to wait for the output of this algorithm or go ahead without it? What do you do in those cases? There's a lot of questions that should be answered very early, really in the early stages of the research. And then once that research is moving, having at least an initial specification for what the inputs and outputs are establishes some tangible objectives for the research work. And in my experience, like, it can really improve your research velocity. That's something that's really hard to measure, but I think every person, every individual that works on a research project knows when they're being very effective and accomplishing a lot and making great progress, and knows when they aren't. You can feel that yourself. And when you have tangible objectives in terms of inputs and outputs, it really helps you move faster and drive towards the finish line. And the finish line is really key here. I think it's one of the often overlooked and like hardest parts about research is knowing when you're done, or knowing when to pause and present your results, even if they're not like fully there, get some feedback, and then maybe dive back in. Another benefit is, since we've defined it, since we've been API first in our thinking, we can actually go write the API. Like, as a researcher, you're doing all this coding in Python or whatever prototyping language you use, you can go build the API yourself. And this has been like the most eye-opening experience for me recently, is getting to go build these things and then see it work, see it in action. So there's several benefits of this. By writing a prototype of the API yourself, it produces some clearly defined interfaces and data specifications. If this technology is prioritized in the product backlog and gets picked up and eventually productionized, a feature or service team is probably going to rewrite the entire thing, and that's okay. But it's still valuable to have a reference implementation that works for them to like work off of and compare with. And I would just like to add, like, your code doesn't have to be perfect. I mean, data scientists come from a variety of backgrounds. For some, if you came out of a software background, a computer science degree, this may not sound scary to you, and you're like, oh yeah, I can just go write production code, that's fine. That's not my background, and so this was not like natural to me to think of trying to do this. But once I just sort of got my hands dirty and sort of came to terms with the fact that I was writing code that, it's still research, right? Like, it's still just for internal purposes. We're not going to make this customer facing. Like, it doesn't have to be perfect. It doesn't have to handle every possible error, every like missing lookup or something. Not all that needs to be handled properly like a production system, but if it works a good percentage of the time, that gets you started, and you can start, iterating and fixing issues. The final benefit of developing a prototype of the actual API yourself is that now you can actually quickly go deploy a demo and basically create something that resembles the envisioned product and get people to experience that. So what are the benefits of building a demo? I think if you go do this, you will immediately see like better engagement from stakeholders. As I said, there's a lot of people posting a lot of things on your Confluence pages every day at your company, and it gets hard at times to rise above the noise, if you will, and get people really engaged with what you're trying to push forward. They're just going to get excited. They're going to think more deeply about what you're trying to sell, if you will. And it's going to facilitate all kinds of interesting conversations that may inspire new ideas for related technologies or new applications of the proposed technology. This, I think, might be the most valuable, at least for the individual researcher. I think you're going to get immediate specific feedback, and it's going to help you learn and iterate faster. And I'll give a really clear example of this from like my own project experience this year. So when you show somebody a demo, when you put it in their hands to experiment with, they're going to immediately tell you whether they like it or they don't. And they're going to immediately tell you why. And that's scary. It's very scary, right? To get that kind of immediate, like intense and like specific feedback. But it's going to help you as a researcher, because if you just miss the mark, you want to fail fast, right? Like if this is the wrong thing and it's not ever going to go to production or shouldn't go to production, then you want to fail fast and move on to something that might. Or maybe you'll figure out it's A, B, and C that are just not quite right, and you can iterate quickly and address the most pressing challenges right now. Or maybe you even hit the mark and you've got something good, and you'll find out quickly. Some last benefits of building a demo that I've, again, experienced myself, and I'll talk about a specific example of this. You're going to outsource some of your initial, I would call it quality assurance, but this is not like specifically software quality assurance. If you can like deploy it internally and put this toy in the hands of other people, they're going to try to use it in ways that you would not have thought of to use it, right? And so they're going to find problems that you did not anticipate, that you did not find easily, or that would have taken you a very long time to identify. So these might just be bugs, problems with null handling, all sorts of stuff, weird problematic corner cases, but then also like all the way up to like more of the product level and the user experience. Like, is this just conceptually not a valuable product to a customer? And that also like user interface, user experience problems. All right, so I wanted to give a real example of that I think illustrates the different response and the different feedback that you can get with like these two different approaches. So this is a real example project that I was involved in this year. And to sort of explain the context of what we were trying to do. So OmniScore is what we call our core fraud prediction model. It's sort of in the core, gives the prediction of how likely, our best estimate of how likely a particular financial transaction or other digital interaction is likely to be fraudulent. It's a large and complex supervised machine learning algorithm, which has a vast number of feature inputs, but suffice it to say, it is very complicated and it is a black box to our customers. So it evaluates all these inputs and produces a prediction. It might say this looks risky, you should decline it. It might say it looks safe, you should approve it. Or it might say this looks kind of risky, somewhere in the middle, maybe hold it and have a human look at it, hold it for review. It comes up over and over again, like it has for years, that customers would love an explanation to ride along with it. Explainable AI is like the big thing right now, right? Everybody wants explainable AI. So we had various forays over the years into exploring these ideas, and took another stab at it this year. And I went and developed a prototype, like wrote a custom random forest parser in Python to parse our OmniScore random forest, given like the Spark formatting of it, and wrote a sort of hacked together a custom feature explainer algorithm in Python. We actually did this work as part of a hackathon, an internal hackathon, soon after the Equifax acquisition, and we won, sort of. Like they gave us a tie for the win, which was like satisfying but unsatisfying. And after the hackathon was over, like we'd gotten some really good excitement. The executives at Equifax were really pumped about the idea. There was some, buzz around the Office account, and I wrote the Confluence page. I was like, well, I gotta go document what I did, committed the code, all that. And I thought, oh yeah, we'll totally build something like this soon. And I waited. This was back in the springtime. And, again, got a thumbs up or two on the page, but nothing happened. So several months later, I'd been working on some other projects that really started to explore these ideas of building the API, building demos, and thanks to the help of Chris and Andrew and others, I now had the ability to just write my own code, write my own APIs, and actually deploy them into AWS. And I just sort of hijacked that infrastructure and added another demo. I just decided, I've got some time. I want to work on something else for a little bit, and I just went and wrote an API in Flask around the model explainer code, which I just prototyped in a Jupyter notebook. It took a couple days to get it all working and deployed out, and then we had it available. And I was like, cool. So the way this works is, we've got a Docker container running a web server in AWS on AWS infrastructure, hosting a Flask API and serving up a web page. That web page has an input, which I'll show you, just an internal identifier for a transaction, an ID, and that gets passed to the API. It formulates a query into our historical data in Snowflake and goes and grabs the journaled features that went into the model when that transaction was evaluated in real time. It pulls back that data, it runs it through this random forest parsing algorithm and creates an explanation of some sort of explanation of the model, why it made the prediction that it did. So this is just the front end, like how it looks, just a very simple web interface that we now have available for internal consumption on our platform. So if you stick in a transaction ID, it's going to give you back some explanation of all the features that may have gone in and sort of their relative contributions towards the safe or risky direction. I'd spot check a handful as part of the hackathon and thought this actually kind of makes sense. It seems like it's producing something useful. But again, this was all stuff, essentially information that was available on my Confluence page write-up of this project. Once I had this deployed out onto the AWS internal system, I sent out a link. It was end of the day, I think, and sent out a link to the rest of the team, some of my coworkers, and said, hey, I just decided to deploy our hackathon entry, the OmniScore explainer algorithm. Go check it out, see what you think. And reminding, after many months of no valuable feedback whatsoever on my Confluence page, it was literally before I got my kids to bed. There was just a bunch of Slack messages about how oh, look at these results. They don't make any sense. This is not useful. And this is not an explanation that explains why this was risky, not that any human can comprehend. And, it was a bummer, right? Initially, what I wanted to hear, I wanted to open up my phone and get into Slack and say oh, this is so cool. It works great. We should deploy it tomorrow. That's not what I got. But I got something really valuable, which was specific feedback and some specific examples about why this wasn't working well. And immediately just sort of started noodling on ideas, what's really going on, first and foremost, what modifications could I make to the algorithm to improve it, to make more reasonable explanations. I'm not going to go into the details because that's not the point. But the real key observation for me was I got that feedback so fast, and it was very valuable. And there was certainly the potential that it could have taken a lot more effort and energy, like for the business to get that feedback. There had been talk about productionizing this, putting it into our new product, and we could have blindly gone off and done that potentially without knowing this. And it's better to discover this internally than externally, right? I mean, one, you don't want your customers like disappointed by your products. You also don't want to put a bunch of effort into building something that turns out to be the wrong thing. All right, so getting to the end here, hopefully leave some time if anybody has any questions, but before I wrap up, I just wanted to give some thoughts. Like, if anybody here that's listening to this broadcast thinks this sounds like an interesting change to some of their own approaches, like what are the important things that you might need to implement these types of strategies? I think first and foremost, like, you have to have a primary interest in learning. Like, if your biggest focus as a data scientist is like getting widgets into production, I don't know, this may or may not be a good path, because you might be able to like put things into production like easier without fully vetting them if you don't build a demo and actually present it. But if your focus is getting the right things in production and like learning how to do that and learning what the right things are, I think this is really valuable. But you have to be willing to accept some direct feedback and criticism. You're gonna get feedback immediately as soon as you hand the keys over to your toy and let somebody else take it for a test drive. They're going to tell you what they think, and it may or may not be good. And so you need a lot of flexibility, right? You need to be willing to part with the idea you had put together in your mind about exactly what you were trying to build and what you were trying to do, and be flexible, be open to change. All right, and in summary, I think more than anything, I want to question this idea that data science is some new and totally different thing, and we should just be following like different patterns in what we do. I think there's a lot we can learn from these other careers and roles that have much better established workflows and patterns for success. And I think a lot of what I'm describing here is about taking ideas from software development and trying to incorporate them into the research pipeline. So this API first thinking that I'm pushing on, I think there's a variety of benefits. It really helps improve communication with your stakeholders much earlier in the R&D process and helps teams get aligned on what they're trying to accomplish. Again, creating that shared narrative about what the goals are. It helps focus the research on the right questions. And finally, it enables the researcher themselves to rapidly develop an actual prototype for the API. With that API implemented and in hand, you can quickly go build a demo, and you're going to get much faster, much better engagement with your stakeholders, and it's going to facilitate feedback very quickly that's very specific and enable you to learn quicker. All right, with that, I think there's probably some venue for which I can be asked questions through the computers.